everyone, we're going to use our double angle formula to find the exact value for the expression secant of 2 inverse tan of 3/4. So basically the form we have is secant of 2 alpha, all right, which is the same as 1 divided by cosine of 2 alpha. So we're going to let alpha equal tan inverse of 3/4. So that means tan of alpha equals 3/4. Since it's positive, that means we're in quadrant 1. Restrictions for my alpha are in between negative pi over 2 to pi over 2, but since it's positive, we're in quadrant 1. All right, so now we have to find the other variables. So what we're going to do is use secant. We're going to use this one right here and find secant, because that's what we have here. So we know that secant of alpha equals square root of tan squared alpha plus 1. So basically I just took this formula and square root at both sides. So I got that. So this means that equals square root of 3/4 squared plus 1. And this equals square root of 9/16 plus, and I'm going to go ahead and write this one as 16/16. And that equals square root of 25/16. 25 square root of 16, I'll break it up. So that equals 5/4. So secant of alpha equals 5/4. That means cosine of alpha, I'm using my reciprocal identities, is 4/5. Now that I have that, I can use my formula here for double identities. We have cosine of 2 alpha, and I'm going to use what I have for cosine. I only have cosine, so I'm going to use this formula. So basically we have this equals 1 divided by 2 cosine squared of alpha minus 1. So this equals 1 divided by 2 times 4/5 squared. There's your cosine of alpha. And then we subtract 1. This equals 1 divided by 2 times 16 divided by 25 minus 1. And that's going to give us 1 divided by 32 over 25 minus 1, which equal, well, let's go ahead and write this as 25 over 25. My 1, the common denominator. So that equals 1 divided by 7 divided by 25. Now to simplify this, I'm just going to move that 25 up there. So it's going to be 25 divided by 7. And that's your final answer. Thank you. Have a nice day. Bye-bye.